In this video, I will show some single-phase AC motors. On the screen is a fan of a type that is typically used in desktop computers. It has two leads, which provides the motor with a DC supply, typically 12 volts. If we open this motor, we find that the fan is integrated with the rotor of the motor, and this is on the outside of the stator. So this is an outer rotor motor. Typically motors are of the inner rotor type, but this is not the case here. On the base of the motor we find a board here with some electronic components. These components are there to switch the sign of the current so that you have AC currents going in these windings. Actually, even though this is sold as a DC motor, it's an AC motor on the inside. On the stator we have 4 windings, so these are electromagnets. When you apply current, you will have a situation where these 2 poles will be, say, north poles, and these 2 poles will be south poles, and then the currents will be switched and the polarity will be reversed. So this is a 4-pole motor or a 2-pole pair motor. On the rotor we have a ring with a permanent magnet, and if you want to find out what the magnetization of this magnet is, this is a useful tool. It's a tiny permanent magnet which can freely rotate. So if we move this device close to the motor, you see that here the blue part of the magnet is attracted, but if we move a little further, the red part is attracted. Here again the blue one, and here the red one. So that means that we have 2 north poles on the rotor and 2 south poles. Again, we have a 4-pole rotor matching the polarity of the stator for a given current. So if there is an offset between the north poles and the south poles of the stator and rotor, then there will be a torque, and in this manner we can rotate the motor at constant speed. Now, in order to know which polarity to apply on the windings, we have to know the position of the rotor, and this is typically achieved with a sensor which is placed between the poles of the stator. And here is the sensor. It's a Hall effect sensor that detects the magnetization here of the rotor, and as a result we can detect the position with sufficient accuracy to apply the correct currents. Now, difficulty with this type of motors is that the resting position of the rotor will typically be such that the permanent magnet is aligned with the stator poles here with the iron, and that is a position of 0 torque. So the problem this could create is that the motor would not be able to start. So features are applied to these motors that will offset the resting position of the motor. And here in this case you can actually see that on the pole a notch was carved here, and only on the right side here but not on the left, and that will effectively offset the resting position of the rotor, and in this manner you will be able to start the motor. Now if you look at this motor here, you can see this effect. You see that the motor does not rest in any arbitrary position, but it will actually rest in a desirable position. Now you can find other types of motor with the same principle. This is a much smaller motor, typically used to cool a chip. So if you remove the fan, you find a similar construction. In fact, it turns out to also have 4 poles on the rotor. And the stator, you don't see the 4 windings. In fact, there is only a single winding on the stator, and this winding is wound around the axis of rotation. So what happens is that if there is a given current, one of the sides of this winding will be a north pole and the other side will be a south pole, and then you have a metal plate here that will guide the flux, so that we will have 2 north poles here and then on the other side, coming from the other side of the winding, you have two south poles, and that will create a motor again with 4 poles on the stator that will match the 4 poles on the rotor. Now here is a motor with a different construction. Again, we find the electronics on the base, and we find here there are only 2 windings, and the rotor here has a disc which is magnetized, but the disc is actually magnetized where the flux will be along parallel directions as the axis of rotation of the motor, and similarly the windings on the rotor, on the stator, sorry, are placed with an axis that's parallel to the axis of rotation of the motor. So if you look at it from the side, you find that the motor in this way, the flux will be going. Again, this is the axis of rotation is this way, so you find that the flux here is directed actually, so this is called an actual flux motor as opposed to the radial flux motors that we had before. But otherwise the principle is the same. There will be 4 poles here. Here we only have 2 windings and instead of 4, but the principles will still work, and this motor will rotate at constant speed, approximately just like the other motors.